Okay, so today's all about parallel and perpendicular. Have you guys heard this stuff before? Okay. Jordan, if I say two things are parallel, can you either define what parallel means, or can you give me an example of two things that are parallel in this room? What? Yeah. So parallel means two lines that will never touch. And the importance of this is pretty much all around us, okay? So if we didn't have parallel lines, our floor would be slanted, okay? Or the tile would look kind of shoddy because the sides wouldn't be parallel. So if you guys look down at the tile, okay, if you look at it, opposite sides of the tile, they run parallel, so you see all those lines. If you look at the ceiling, the lines on the ceiling that hold the tiles in, they're parallel. But even more so, doors. The sides of the door are parallel. Why does that matter? Well, if the sides of the door weren't parallel, the door wouldn't shut. Okay? And if you guys ever have that problem at your house where your door won't shut, it's because your door is not being parallel. Like the hinge is kind of like coming off. So you have to refasten it to the wall. Got that, Harshawn? So parallel lines are very, very important. Okay? But as of right now, we just know what they look like and we know why they're important and what they are. We don't know how to like show two things are parallel or prove two things are parallel. Now let's talk about perpendicular. Have you guys heard of perpendicular? All right, you're shaking your head, Sophie. What is perpendicular?
I know what it is, I don't know, like,
Can you give me an example of two things?
Cross.
Okay, lines that cross. So, like that wire that's falling down up there above my clock, that's like a line, right? Yeah. And like a line on the wall, like from the cinder block. Are those perpendicular? They cross, right? Are they perpendicular? You don't know. All right, can you give me an example? Just look around the room, and when you see something that's perpendicular to you, just point it out. Can't think of it? Okay. So perpendicular lines are two lines that intersect to form a 90-degree angle or a right angle. Okay? So basically what that looks like, it's like the corner of a box. Okay? That's what we're thinking of. It makes like a perfect L. All right? So if you look at the ceiling, okay, I really like the ceiling. Okay? All right, sometimes in high school I would count the dots on the ceiling because I was bored. Okay, there's a lot. All right, but if you look at the lines that are going this way, all right, front to back, and the lines that are going left to right, those lines are perpendicular. They intersect to make a 90-degree angle. If you're at your house, okay, kind of think of, where your ceiling intersects your wall, okay, like in the corner. That makes a perfect L. That should, not saying it's perfect, okay, depending on what type of house you live in. If you live in an older house, it might not be perfect anymore. I believe they call that plumb in construction. Okay, if things aren't perfectly plumb because things have shifted, then they're not perpendicular and they're a little off. And that can make your life a little miserable. So perpendicular lines are very important. All right, so now that we know what parallel lines are, they're two lines that never intersect. And we know what perpendicular lines are, lines that intersect to form a 90-degree angle. We can start with this. All right, so first thing we need to do is we cannot graph these lines in our graphing calculator. We can't do that because they're not y equals. If we look at our calculator, there's a button in the upper left-hand corner. Do you guys want to look at it? I know you guys can't see it, so I'll pull it up. So if we look at our calculator, we can see in the upper left-hand corner, there's a button. And it says y equals, meaning that's the form they want your equation to be in. So we talked about point slope, right? This won't graph an equation in point slope. This won't graph an equation in standard form, which is what's up here. The only way it graphs is if it is in y equals mx plus b, okay? So we have to take these lines here for A, And we need to get them such that y is by itself. All right, so okay. Not a problem, Destiny. We're just on page, I believe it is what, 29? 29. All right, so up here we have 3x plus 4y equals 6. So the first thing I'm going to do is I'm going to subtract that 3x from both sides. So everybody, let's subtract 3x from both sides. That's going to give me 4y equals, and I like to view this number as falling off the back, negative 3x plus 6. I'll give you guys a second to write that down. After that, we're going to divide by 4. We're going to divide everything by 4. Y equals negative 3/4 x. 6 over 4, I could leave it as 6 over 4, Harshan, because we're going to be plugging in the calculator. But that reduces to 3 over 2. Okay? So we're going to say this is my blue line. Okay? Now, for the second one underneath A, I'm going to go ahead and I'm going to subtract 3x. Okay? And that gives me 4y equals negative 3x. View that as falling off the back, plus 12. Now I'm going to divide everything by 4. That gives me y equals negative 3/4 x plus 3. This is going to be my green line. All right. And then here, with the last one, we're going to go ahead and subtract 4x from both sides. That gives me 3y equals negative 4x plus 12. Divide by 3. And that gives me y equals negative 4/3 x plus 4. And this will be my red line. Now that I have these 3 lines in y equals mx plus b, what I'm going to do, Jordan, is I'm going to hit that y equals button. I'm just going to plug them in. So here we go. Let's all plug them in together. We're going to hit y equals. If you have anything in there, I teach another class, so I have stuff in there. If you have a brother or sister that uses your calculator, make sure that you clear that out. So in my first line, I'm going to plug this in. But I don't need to plug in the y part. I just need to plug in this back half. So I have fractions, so I'm going to make sure I plug my fractions in parentheses. So I'm going to plug in negative 3/4. Okay, do you see that, Drew? X. Now this is x right here. Okay, I know there's other letters down here in blue, but this is the button you want to use. This is your variable button. So I hit x plus, and then I'm going to type in 3/2. So that's my first line. You okay with that, AJ?
Yeah.
Now my second line, that green one, same thing, okay? I'm going to be typing in the negative 3/4 in parentheses, and it's very important to plug it in parentheses, because sometimes when you don't use parentheses, Harshan, it kind of follows order of operations, what might not be what you want, okay? So get in the habit, fractions go in parentheses, okay? And now I'm going to do plus 3. Emma, you with me?
Yep.
All right. And then the third line, this red line down here. Okay, I'm going to type in negative 4/3 x plus 4. And now I'm going to hit graph. Okay, and these lines came up. All right. Now, the first line that appeared was the blue line. The second line that appeared was the green line. And the last one that appeared was my red line. Now, Jordan, you told me parallel lines never touch, right? What two colors don't touch? Green and blue. Now, if we look over here, right? Let's look at the green line and the blue line, right? That was the first one and the second one. How could I have figured out that those two lines were parallel without graphing? They have the same slope. So lines that have the same slope are parallel. All right? You guys okay with that? Kind of know that? You guys done that before? Jordan, have you done that before? Did you guys do it last year? Okay. So we have that. Now that you guys can do that, why don't you try B? All right. So why don't you guys try B? Try to figure out, without graphing, are these lines parallel, perpendicular, or neither? Okay. View them as 1, 2, and 3. Was everybody able to get to this point? Let's go with Hope. Were you able to get to here?
I'm doing it now.
Okay. Nate, were you able to get to here?
Yeah.
Awesome. Okay. Now, Jordan, you said none of these are parallel, right? Okay. And here's the thing. There is a pair that is parallel, right? Do you want to take a guess at which pair is? Third and first. Okay. Now, the thing here is this is a decimal, right? We don't write our slope as decimals, do we? We typically write it as a fraction. So what you're going to want to do is you're going to want to take 2.5, plug it in your calculator, and hit math, enter, enter, meaning this. Okay? So we don't want 2.5. So I type in 2.5, I hit enter. I'm going to go up to math. I'm going to hit math, enter, enter. So it was -5/2 for the last one. Okay? So you have to kind of like play the game with making sure all of your answers are in the same form. Okay? This is a fraction. That's a fraction, even though it's a whole number. It's -2/1. But this is a decimal. So I need to make sure I put them all in fractions. That's why that one was so easy. Okay. All right, same thing here. All right. What I want you guys to do is I want you to get these 6 problems, okay? The 3 in A and the 3 in B. I want you to get them all such that y is by itself. And then I want you to look at the slopes because, as Jordan said, because today's all about Jordan, okay? Jordan said it's all about the slope, okay? Kind of like the song All About the Benjamins, okay? This is like all about the slope. So you need to pay attention to the slope. Look at the slope. See which ones might be perpendicular, okay? There's something about the slope that will make 2 lines perpendicular. Just like with parallel lines, the slope was the same, perpendicular lines have something going on. All right, this is what you guys should have gotten. Kevin, did you get this? Kevin,
Yeah.
you got all these?
Yep.
All right, so this is what we got. Now let's look at A. A says, which one of these pairs of equations are parallel? Is it like the first and second, the first and third, or is it the second and third? Well, how do I know? Drew, do you know? Which ones are perpendicular?
The first and third,
The first and third. Why is it the first and third?
the slopes are different.
Well, the slopes in the first and second are different as well, right?
Well, like, it's also because the y-intercept is lower and the slope is higher, so they eventually catch up and cross.
Okay, well, this one's lower than that one. I'm not saying you're wrong, you're right. Okay, it is the first and third. But why? We can't just say that the slopes are different, because that doesn't make two lines parallel. But there's two things that are not parallel, perpendicular. There are two things that make a line or lines perpendicular. What are they? All right, you've identified the two. So let's look at the slopes, right? Look at that slope. What type of number is it? Positive or negative?
Negative,
And this one is?
positive.
So they have to be opposites, okay? That's the first thing. Lines have to have opposite slopes. The second thing they need are, well, let's look at the numbers now. This is 3/4, and that's 4/3.
Opposite y-intercept.
Not y-intercepts, but what are that? Just look at the 3/4 and 4/3. What do we do with those numbers?
You flip them.
You flip them. So they're opposite and flipped, right? The fancy word that they use for that is reciprocal. Don't ask me to spell it, I don't know. Okay? So opposite reciprocals. Okay? So one's positive, one's negative, and then one's like flipped. 3/4, 4/3. Make sense? Over here though, Sophie, which lines are perpendicular?
They're all different, but
They are. What should you do first?
either positive or negative.
Yeah. But what should you do with
Oh.
2.5? Convert it to a fraction. Okay? So use your calculator. What is it? Not 1/5. Type in 2.5 in your calculator. And then do math, enter, enter. So, yeah.
Oh, sorry. We just did that.
Yeah. I know. So which lines are perpendicular? Yeah, the first one and the third one, the blue one and the red one. Because the blue one is -2/5. And if we convert 2.5 to a fraction, that's 5/2. And you can see one's positive, one's negative, and one's 2/5, and the other one's 5/2. So the key here is that they're opposite reciprocals. All right. So how can you recognize lines that are parallel or perpendicular? Parallel lines, same slope. Perpendicular lines, slopes are opposite. Here we go. You ready for this? Reciprocal. Hope that's right.
No,
That's why I teach math. How do you spell?
You just replace the O for an I. Reciprocals.
Oh, it's an I?
Yeah, it's an I.
When did that happen? Did we get a memo this morning?
It's always been I. It's
Since
not
when?
reciprocals.
Oh, this is not.
Yeah, that's an I.
I mean,
It's pretty good.
it's pretty close. I mean, it would have fooled everybody else.
Yeah, I would've.
Yeah, nobody would have.
I just been like, okay.
Cool. This is math. Thanks, Drew. Thanks. Now this guy go on YouTube, and people are gonna know I can't spell. Like I care.
Or you teach snap pointer.
That's my point. That's why we have spell check and grammar. Okay. So do you guys see the difference? Now compare the slopes of the lines in explanation one. How can you use slope to determine whether two lines are parallel? We discussed this. I'm not writing it down. Okay. We can determine in explanation one, which was the first one, the lines that had the same slope were parallel. That was easy to identify. Graphically, as Jordan said, it was two lines that never touched. Now, the thing about that is just because they don't touch on the screen doesn't mean they don't touch eventually. So that's why we have to know that they need to have the same slope, okay? And then in explanation two, how do we know that two lines are perpendicular? Their slopes were opposite reciprocals, okay? Just because they didn't intersect on the screen doesn't mean that they're not perpendicular, okay? They could be perpendicular. We just might not be able to see it. All right. All right, why don't you guys fill in these two, and then we'll call that a day. All right, so right up here, how can you tell that two lines are parallel? By looking at their equations. And how can you tell that two lines are perpendicular? By looking at their equations. Filled in your own words. Could be the same as my words, or not. Just these two, and then we're gonna stop there.